All right, we're going to look at another derivative problem here. So we're supposed to find dy dx for y equals this function of x. And like the last video, one of the important things to notice here is that I have a variable in both the base and the exponent. Right? Variable to a variable power. So my usual differentiation rules for differentiating x to a constant power, variable to a constant power, that rule doesn't apply here. I don't have a variable base to a constant power. And I also have a rule that I know for differentiating constant base to a variable power, but that also doesn't apply here. I don't have a constant in the base, although I do have a variable in the exponent. So those rules don't apply. So remember that we can use logarithmic differentiation to do that. Okay, so in logarithmic differentiation, we're going to start by applying the natural log to both sides of the equation, and then we can use a property of logarithms to help simplify. So I have y equals x to the cosine of x, and I'm going to apply the natural log to both sides of that. The whole point of doing that is that I can then use a property of logarithms on the side that has a variable to a variable power. You can use that property of logarithms that allows you to bring that exponent out front. So the left side of the equation then is still ln y, but the right side of the equation, you'll have cosine x times natural log of x. So I no longer have variable to a variable power. So I can now just use my ordinary differentiation rules. I don't have y equals though, so I do need to use implicit differentiation to finish this. So I'm going to differentiate both sides with respect to x. On the left side, when I do my implicit differentiation, I'll think through the derivative of natural log of y is 1 over y times dy dx. That's chain rule, and that's actually the implicit differentiation part right there. And then on the other side of the equation, this is just a basic product rule. The derivative of the first function, derivative of cosine, is negative sine times the second function plus the first function times the derivative of the second function. So the derivative of ln of x is 1 over x. Okay, at the end, when I do implicit differentiation, I would like to solve for dy dx. So I'm going to multiply through the whole equation by y so that I can solve for dy dx. So on the left side of the equation, I'll have just dy dx equals. And then on the right side of the equation, I'm just going to leave the y times this whole expression here. Negative sine of x times natural log of x plus. And then I can leave this last part like it is, or I could write that as cosine of x over x. Okay, so this is an okay answer. But a better form of the answer would be to notice that the original equation, I have y equals something given completely in terms of x. So I could rewrite this answer by just replacing the y that I have here with what it is at the beginning so that I have my answer completely in terms of x. So I'm just going to put that and leave that out front. So in place of the y, I'll have x to the cosine of x, and then times this whole expression here. Okay, so again, I used logarithmic differentiation because I started with variable to a variable power, and so my usual differentiation rules didn't apply. So applying that log to both sides of the equation allowed me to rewrite it in a form where I have some rules that will apply. All right, thanks.